Hello. In this video, we discuss about products of vectors. So here you can see unit vectors I, J and K. So unit vectors are vectors actually. Unit vectors here I, J and K, they have magnitudes 1 unit each, 1 unit magnitude each. I is directed in the x-axis, J in the y-axis and K in the z-axis. Okay, they are directed along the x, y and z axis. For example, here I, J and K, for example, these are the directions x, y and z. The angle between I and J is 90 degrees. Angle between J and K is 90 and K and I is again 90 degrees. However, if you take two I unit vectors, I and I, angle between them is 0. They are parallel. J and J again, angle between them is 0. And K, the angle between two unit vectors along the z-axis K and K, the angle between them is 0. Now, products of vectors. That means multiplying vectors. So when we multiply two vectors, you can do it in two different ways. The first one is called scalar product or dot product, or we represent it with a dot. The second type is vector product or cross product. We represent it with a cross. The difference is, in a scalar product, you take product of two vectors, you get a scalar value. That means without any direction, only magnitude. In the case of vector product, you multiply two vectors and you get another vector which is perpendicular to the vectors we are multiplying. So I will explain that in the next slide. So first we will deal with scalar product. Here you see there are two vectors A and B. A and B. You can see here A and B, they are not parallel to each other. A is represented here AXI plus AYJ plus AZK, where AX, AY and AZ are the magnitudes of components along X, Y and Z directions. Here IJK represents X, Y and Z directions. Similarly, another vector B is represented as BXI plus BYJ plus BZK. So the scalar product is defined here. A dot B, here see A dot B is equal to AB cosine phi. So what is this A and what is this B compared to the left hand side A and B? On the left hand side you have A with an arrow on top. That means it's a vector. Okay, this is what it is. B is this, is a vector. But on the right side, this A and B without arrows represents its magnitude. So what is the magnitude of vector A? You can calculate the magnitude of vector A as root of AX square plus AY square plus AZ square. Okay. If the vector is in the plane XY plane, you will not have this component, this value AZ. Okay. Similarly, for B, the magnitude is root of BX square plus BY square plus BZ square. So you see, what is the angle here? Phi. So we have to take cosine of this angle. This angle is between the two vectors. Okay. So how to calculate A dot B is basically, you have the vector A and vector B here. You multiply each terms of vector A with the corresponding terms on the second vector. So first I am going to multiply AXI with BXI. Okay. Then I will multiply AXI with BYJ. then AXI with BZK. So subsequently you have to do the other terms, you have to do the multiplications for the other terms. Okay, so you can see in the first case AXI multiplied by BXI, AX, BX, then you have I dot I. So what is I dot I? Using this formula, you know, I is a vector. Again, here instead of A, if you put I, okay, and instead of B, if you put I dot I is equal to magnitude of I is 1, magnitude of B is 1. So AB means here I into I, 1 into 1. Cos phi, what is the angle between I and I? It is 0. So cos 0 is 1. So in the end, I dot I is 1. So AXI multiplied by BXI will yield AX BX multiplied by 1. Okay, so it is AX BX. Second, AXI multiplied by BYJ. You see that I dot J, I multiplied by J in the scalar product, it will become 0 because the angle between them is 90 degrees. So cos 90 is 0. I and J, you know that the angle between them is 0. So we get 0. So that term vanishes. So you see that the only terms which are identical unit vectors, they will stay. If they are different unit vectors, cross product, dot product if you are taking, then those terms will vanish. So these are the multiplications, and you see in the end what you get: AX BX plus A by BY plus AZ BZ. This is what you get in the end. So A dot B is this. Now the scalar product of two vectors or dot product, if you take it, you can consider it in a different way. For example, A and B are two vectors. Angle between them is phi. So if you look at here, A parallel, what is A cos phi means? A cos phi is this component of vector A in the direction of B. Okay, so that is A cos phi. Similarly, what is B cos phi means? Component of B in the direction of A. So in summary, the scalar product A dot B of two vectors is a number. So what you get in the end is a number. There is no direction involved there. So it is a scalar quantity. That's why this product is called a scalar product. A dot B is equal to AB cosine phi. And the multiplication of this unit vectors I already discussed. I dot J, J dot K, J dot K, all these multiplications results in 0 because the angle between them is 90 degrees. But I dot I, J dot J and K dot K, you will get 1 because the angle between them is 0. The scalar multiplication of vectors, you see here, it is commutative. Commutative means the order doesn't matter. A dot B is equal to B dot A. Also, it is distributive. That means first you add, here you have three vectors, okay? On the left hand side, you see, first you add B and C, which is within the bracket. Two vectors B and C, you add them. Then you are taking a dot product with A. So A dot B dot C. On the right side, you see, first you take the dot products of B and C separately, and then you are adding. So both ways are similar. So they are equal. So it is called, it's distributive. Okay. The angle phi between two vectors, how to find? For example, you have two vectors and you are asked to find the angle between them. So you can use this dot product to find the angle. How? You see A dot B. We want to find the angle between A and B. We know what is A, we know what is B. So A dot B, you get AX BX plus AY BY plus AZ BZ. What is A? What is B? A is the magnitude of A, B is the magnitude of B. So cross multiply this AB here to the denominator. You can calculate cos phi. So what is actually this A? A is root of AX square plus AY square plus AZ square. What is B? Root of BX square plus BY square plus BZ square. So using this, you can find angle by taking cos inverse of this part. Okay, so this is an example. You see there are two vectors u and v. Here 2, 2, 0, 3. What are these numbers representing? So here 2 is ax, for example ux, and this 2 is uy. Here vx is 0, vy is 3. So using this identity here, so you can solve this example. Next one is called a cross product. Cross product is the second type. The difference from the first scalar product is that when you do a cross product, you get a vector as a result. So here you see A is multiplied with B, A cross B. See, A cross B. In the end, you get another vector C, which is perpendicular to A and perpendicular to B. So there are two vectors multiplied, you get a third vector which is perpendicular to both of them. So now there is an important thing to note, that is A cross B, when I multiplied, the vector is pointing up, right? But if you multiply B cross A, that is if you reverse the order, the resultant vector changes its direction to down. So B cross A is minus C. You see, the direction is different. So the vector product is a vector that has its direction perpendicular to both A and B. How to find the length of this vector? Okay, how to find the direction, I will discuss in the next lecture, next slide. Here, how to find the length of this vector or the magnitude of vector C. The magnitude is A cross B is equal to AB sine phi. Okay, here A is the magnitude of A, B is the magnitude of B, and phi is the angle, smallest angle between A and B. So how to find this part, A cross B, we will discuss later. A we know, root of AX square plus AY square plus AZ square, and similarly B also we know. So we can substitute that. Phi is sine phi, this phi is the angle between them. So this is how we can find the magnitude of the resultant vector. You see, important things to note, A cross B is equal to minus B cross A. The order matters. So how to find the direction? To find the direction, you are multiplying a vector A with vector B. So A cross B, if you are doing, we have to apply corkscrew, right hand corkscrew rule. So what it means is, use your right hand, point your fingers in the direction of the first vector A, then rotate these fingers to B. So A cross B, you see the thumb is pointing up. So the direction of C, the resultant vector, is in the direction of the thumb. Suppose if you are doing B cross A, you have to rotate your palm, pointing your thumb down, point your fingers to B, rotate it to the right side. So you see that the thumb is pointing down as I will show you in a video now. So what it's here, A cross B is you have your fingers are pointing in the direction A, you rotate it to B, the direction of the thumb is the resultant vector. See. Now look at this video. Suppose this pen represents A and the white pen represents vector B. Okay, we are going to multiply A cross B, A cross B. Okay, so first point your fingers, right hand fingers to A and rotate it to B. The thumb is pointing up, so the pen, the third pen is the resultant vector which is perpendicular to both of them. Now if you do the opposite, B cross A, you cannot rotate like that, so your thumb will point down and rotate it to the direction of A, so the vector is pointing down. Okay, here about the cross product, it also follows distributive property. You see there are three vectors here, A, B and C. B is added to C first and then you take the cross product with A cross B plus C. But on the right hand side you see that first you take A cross B, then you take A cross C, then you add. Okay, so both results are same. So A cross B plus A cross C, you take the cross products first, then adding, or first adding and taking the cross product, doesn't matter. Okay, so both are same. So the rules here is, for the unit vector multiplications here, you can see that I cross J will give you K. Why? Because the vector which is the result of I multiplied with J should be perpendicular to I and J, right? So I cross J, the vector is K. So why it is in the positive direction of Z axis? Because if you put your fingers in the direction of I, you rotate it to J, thumb is pointing to Z direction. So K, I cross J is equal to K, J cross K is equal to, similarly J cross K will give you I, and K cross I will give you J. Okay. The reversing the order of multiplication gives you negative values, minus J, minus I and minus K. So vector product of two vectors, the cross product here, A and B, will give you a third vector C. The magnitude of that vector is AB sine phi. Okay, angle between them is the smallest angle. Okay, so which one to take? You have to take the smallest angle between the two vectors. So phi is the smaller of the two angles between A and B. Now direction of the result vector is perpendicular to both A and B. For example, here you have A, B. Imagine that A and B is lying on a plane and you are taking A cross B. So A and B both are on this plane. So when you take A cross B, first you put your right hand fingers in the direction of A, rotate it to B, your thumb is pointing in the direction of this green arrow. So that is A cross B. But in the other case, if you do B cross A, so your fingers are pointing here, but if you want to rotate your right hand, it will go to the thumb will point the down direction here, the opposite direction as shown here in as the green arrow. So minus A cross B. Okay, so the order of multiplication is important in the case of cross products. Now if you take IJ, okay, IJ, so this coordinate system is different from the other one. Here we are taking this direction as positive. So I cross J, if you take I cross J, it is IJ sine phi, right? So the angle between I and j is 90 degrees. So sine 90 is 1. So sine 90 is 1. The magnitude of I is 1. Magnitude of j is 1. So in the end, I cross j is, the magnitude is 1. But what is the result you get? You use your right hand corkscrew method. Then the direction of the resultant vector will be up k here. Okay, I cross j. What if we reverse the order j cross I? So I cross j is k. What if we reverse the order? Then we are multiplying in the reverse order. You get minus k. Okay, minus k. So j cross k, same way, if you do, we get I, and if we reverse the order, you get minus I, like this. So k cross I, you are multiplying from k to I here like that. So this is the direction, okay, which will come. It is j, k cross I is j, and I cross k, it will give you minus j. Okay. So I, j and k, you can use this triangle to remember. I cross j will give you k, which is this k. But if you reverse the order of multiplication, j cross I, it will become minus k. So j cross k gives you I, but so if you go in the clockwise direction, these are the positive values. If you go in the anti-clockwise direction, it will be negative. So j cross k will give you I, but k cross j in the opposite direction gives you minus I. Here k cross I will give you j, and I cross j gives minus j. So now we were multiplying two different unit vectors. What about I cross I, k cross k, j cross j? So because it will give you 0, because why? The angle between them is 0. So sine 0 is 0 in all these cases. So if the multiplication involves same unit vectors, you get 0 values. Okay, so look at this table here. J cross I cross j, I cross I, j cross j. We have to use this information to find what we get when we multiply a and b. Okay, now we are going to find what is on the left side of this, a cross b. Okay, so axi plus ayj plus azk cross product with bxi plus byj plus bzk. So each term you are going to multiply with the corresponding terms on the right, the other vector. So you can see here I cross I. When you multiply this I and I, it will become 0. J and j become 0. K and k multiplication, it will be 0. So the after multiplication, the terms which are involved with the two different unit vectors, they will stay. If they are same, they will vanish. So if you multiply all of them, what you will get? Okay, so there are two vectors. I will demonstrate. There is an easy way to find out. I will show you how to get it. So here there is a vector a, vector b. We want to find a cross b. So if you know about determinants, okay, how to find determinants, that comes handy here to find this multiplication and result of this. So how to find a cross b is, first you write down here I, j and k. Then the next row you put ax, ay and az. The third row will be ax, by and bz. Now how do we calculate the determinant? First term is I. Okay, first term is I. So you take I. Then no need to consider these two terms and these two terms here. So first column and first row you need not to consider. So I multiplied by AY multiplied by BZ minus AZ multiplied by BY, like this. So I multiplied by, in bracket, AY BZ minus AZ BY. Then you take J. So when you take J, this row and this column, the second column, is not considered. Okay, that column is not considered, that row is not considered. So J multiplied by, in bracket, AX BZ minus AZ BX. Okay, but here you have to remember, you have to put a minus sign. So minus J AX BZ minus AZ BX. The third term, so it is plus, minus, then plus. The third thing is you take K. So the first row is ignored, last column is ignored. So K, so plus K multiplied by, in a bracket, AX BY minus AY BX. So this is what we get when you do the multiplication. So A cross B is this one. So remember, plus minus plus, right? Suppose if you want to change this minus sign, what you can do, you can take this minus sign or multiply inside, so that what happens is this term becomes minus and this term becomes positive. So here you can make it positive, so as shown here. You see, AX BZ is written here, AZ BX is here. Okay, so you can either write like that or like this. This is how you calculate how you measure the cross product.